Good morning, or afternoon, evening, middle of the night, wherever you might be. My name is Sarah Forcier, and I am the manager of the RenderMan integrations team. So this is the team that develops and supports RenderMan's bridge products, one of those being RenderMan for Houdini. In recent releases, RenderMan for Houdini has included support for rendering in Solaris, which is Houdini's scene building, layout, lighting, and rendering tool based on Usd. We've been working hard to bring new RenderMan features such as XPU and Llama to the render delegate in Solaris, as well as supporting the awesome new features SideFX has been working on as well. So today we'll be talking about the intersection of Usd, RenderMan, and Houdini. First, we have George Elkoura, who oversees Usd development at Pixar, who's going to be joining us to give an overview of Usd and talk about recent developments. Then we'll get to see this technology in action when SideFX's senior product designer, Scott Keating, gives a demo of RenderMan in Solaris. And then at the end, we'll have some time for some questions. So whether you live and breathe Usd or have never heard of it, I hope you learned something new today about this brave new pipeline. George, over to you.
Awesome, thanks, Sarah. Hi, I am George. Let's see here. Let's see if we can figure out how to share a presentation. I have some slides to share with you. Okay, awesome. So I'm George. I'm the director of engineering at Pixar, and along with some of our proprietary software, I oversee the development of Usd and Hydra, which I'm here to talk to you about. And I'm here obviously representing the work of a boatload of people for whom I am extremely grateful. Okay, before we go on, there's a poll that will give me an idea of whether or not folks here are super familiar with Usd or have never heard of it. So if you click on that poll, I've got the presentation broken up into little sections that ideally can serve folks who are super familiar with Usd and also folks who are new to Usd. So I'll concentrate on each part depending on how many folks we have. Okay, so most folks seem to know a little about Usd, and we even have some folks who eat livers and peas for breakfast, so that's really good. Okay, before we get started for real, I just want to show you where we use Usd and Hydra in our pipeline at Pixar. This is super simplified, obviously, but the idea is that we use Usd and Hydra basically everywhere. All the blue arrows represent the interchange between our applications that we use Usd for, and of course, that doesn't include the use of Usd within the applications, which again is most of them. And then Hydra is we use Hydra also in most of our applications, and Hydra today at least serves as the viewport for all of this stuff. Okay, so what's Usd? Usd is a platform, and we're fond of saying it's not a file format that lets you describe, transport 3D scene data in a powerful, collaborative, and non-destructive way, and that's really kind of the key bit there. At the heart of Usd is its composition engine, and so this engine is really what sets Usd apart. What's nice, and you'll hear me say this again, is that it's how all of these operators work together that makes it powerful and lets you build workflows that suit your pipeline. And let's talk only about a couple of examples. So references. References are basically what you'd expect of references in any other system. You have the model described in a particular place, and then you reference in as many copies as you want into your scene. But what's cool about what you're able to do with Usd is that not only can you bring in the references, but you can add opinions on top of what you've referenced to change things non-destructively. For example, in this case, I brought in 3 references of the model and changed the display color on 2 of them. We call the opinions of the new colors overs because they compose over the reference that's brought in. So that's already kind of a cool feature that lets you work non-destructively, and a lot of people use that. So okay, the other thing is variance. So variance are interesting in Usd, and I was asked to describe variance in particular to set up a cool demo that you'll see Scott show with this stuff working in action. So that'll be much more interesting. But So variants let you encapsulate your model with options about some variations. In this case, I have a shoe that I can reference in and then select the style that I want. This is an example of our composition operators all, again, working together. And you see here, I also override the display color on the shoe that I brought in as well. But wait, it gets more interesting. So just as overrides and references and variants can work together, well, variants can work together with other variants. And so in this case, you get nested variants. And we can build up really cool and complex structures. In this example, we get, I'm saying I want to bring in this shoe with a particular style, but then I also want the low complexity version of that shoe. So that's pretty cool. And some of these model structures can get pretty crazy. And one thing to note for those who eat their liver peas for breakfast is that once you actually look at the composed stage, what you see is kind of all of those things resolved. So you don't necessarily get to see what all of the variants that are composed at once. We only do the selected variants. And so when you're authoring to those places, one gotcha is you could potentially be authoring to a particular variant where you really meant to author globally or vice versa. So you have to be careful about that. So that's a gotcha. Hopefully it's a nugget that you can walk away with and have this not be a total waste of your time. Okay, so on to Hydra. Let's talk about Hydra for a bit. Well, so when we first started working on USD, we decided that it was super important that we had something that can, with high fidelity, show you the contents of your USD file. This was called Hydra, and it was a smashing together of a fast GL renderer that we now call Storm and the Hydra core. We quickly pivoted with that notion, and we decided that Hydra can abstract away both the renderer and the scene from each other, so we can start mixing and matching them, and I'll show you what I mean. So in this picture, we have a scene coming into Hydra, and then Hydra talking to as many renders as you have installed. Internally, we use Storm, that's the top one, and RenderMan, the bottom one, and we also have we wrote a quick Embry-based ray tracer that just shows you an example of how you can integrate your renderer into Hydra. You can get the code for everything here for Hydra, Storm, USD, obviously everything, and HDPRMan on our GitHub page. So the flip side of all of this is that if you integrate Hydra into your app, then you can automatically take advantage of any renderer that supports Hydra. For example, Scott's going to show you Solaris, which has Hydra embedded. Now, with our render delegates, specifically HDPRMan, you can have RenderMan running in any app that has a Hydra viewport. And that's super cool. And the fun part, of course, is that this middle part, this Hydra core part that we talk about, is about to get much more interesting. We put out a white paper a few months ago that show some major changes we're making to Hydra to allow it to not only transport the data from the scene to the renderer more faithfully, but also allow some transformations along the way. And that should open up the door to a lot of cool new features. Okay, for example, and again, here I'm just going to dive in real quick for some of the advanced folks, if there's one or two people who can get a kick out of this. But our old API, in order to write against the scene delegate, both on both ends, consuming it and producing it, the API is a little bit overwhelming, and there's a lot of bespoke APIs you have to end up calling to get your scene data, which could be a little bit frustrating for folks. And so that's obviously feedback that we got and took, and it doesn't have to be that frustrating. With the new work that we're doing on Hydra, you'll be able to get at everything with very simple API, and nothing will be hidden from you. So if you want the full transform hierarchy, and this has been a popular request, you'll get the full transform hierarchy. If your renderer prefers things flat, like Storm does, and we'll continue to flatten it. So it'll be nicely extensible and customizable. So hopefully everybody will be happy. So okay, I'm going to stop myself right now, and I'm going to ask you to please come and check out our BOF at SIGGRAPH. It'll be great and a super fun time, and hopefully, well, I can't guarantee that, but we'll do our best. And so thanks so much for your time. I really appreciate it. And now I'll hand it off to Scott to show you some really cool stuff in action.
Yeah, thanks so much, George. Let me see if I can get this set up here. Hello, everybody. I'm just going to load up my presentation here real quickly. And I want to thank everybody at RenderMan for inviting me here to do this talk. It's always awesome to participate in these. And I hope what I show lives up to all of the descriptions that were just given of it. Okay, so today what I'm going to be talking about is Houdini and Solaris, which is basically our node-based interface to USD. And of course, along the way, we're going to take a look at RenderMan and XPU. But at a high level, we're going to talk about asset templates, basically a way of sort of having things built for an artist to just fill in so that they don't have to do all of the tasks themselves. Automation, even working from a template and then automating the creation of various tasks. Variance and class prims, which are really awesome ways you can define primitives in your scene using USD. And then finally, instancing is a way of just bringing it all together. So let's just jump right in, I guess. So here I've got a template set up. And the idea here is that an artist can jump in and have like a place with some lights already set up. You see we've got sort of a cyclorama. None of that will get written to disk when you write this template out. And essentially, all an artist has to do is, fill in all of the relevant information. So in this case, we're starting with this awesome walking teapot asset. And basically, we're just going to reference this into our scene. You can see that because we have this cyclorama in this background, we're getting lights and things automatically. And you can jump right over to RenderMan and take a look. And RenderMan generally is nice and sort of interactive. But since we have XPU now, let's take a look at that kind of performance. When you switch to XPU, there is sort of a pause as it puts things onto the GPU, but then you pretty much get a very close to final image almost instantly. And you can see how much more interactive it is than normal RenderMan. But anyway, let's move forward. So all we're going to do now is go into this template shader and basically just go ahead and fill in all the things like base color, roughness, metallicity, and those kinds of things. And again, you can see how nice it is having XPU running while you're doing this because you're basically sort of look deving on the fly. Now, obviously, this is a bit of an idealized case because I'm just filling in texture maps. But any of the work you might normally do with the shader would happen this way. So you could tweak things, get things to look good, and then you have basically, a very close to final image looking result running there in the viewport, which is really, really nice. And so basically, now that we've got that set up, we can more or less just write this to disk. But let's talk about adding variations to this, because that's an important part of working with assets. So what we're going to do now is add what's called a variant. And we can do that in a couple of different ways in Solaris and in Houdini. We're going to use this add variance to existing primitives node. And it basically gives you this little setup where on the right you put your variance, and on the left is sort of what you're adding the variance to. So we're just going to fill out some parameters here. And basically all we're going to do is edit the material, because we don't want to include in our variance the entire material, or even worse, all of the geometry over and over and over again. And USD allows you to do these kind of specific overrides, where all we're doing is saying, I want to override, for instance, the base color. And now that variant just includes that instruction to do that override. It doesn't include the entire material and the entire geometry, which is really nice. That allows it to be very scalable, and also lets you really target exactly what your variants are doing. And so you can see here now we've got that set up. I can come down here and put that a set variant node. And it's a little off screen there, but you can see I can switch between the scales variant, and the normal sort of rusted metal variant. So, okay, let's go ahead and add another one. Luckily, we can just copy and paste these nodes, do a little bit of renaming, and change our texture map. In this case, we're going to go with sort of a wooden-looking teapot, plug that in, and now things, again, are working really nicely. We can go back down to our set variant. We can go ahead and pick the wood, or we can go back to the scales, for instance. So everything is sort of working the way you would expect, and you have a nice clean network. But suppose you had lots and lots of these, right? You have 10, 15, 20, 100 variants. This is going to start to become, a bit tedious. Certainly possible, and there's cases where you definitely want to have the network like this. But what I wanted to do is take this a bit further and show a little bit of how XPU can help us automate things as well. So the first step is that I basically built this little network that just extends our template and adds in this section specifically for doing all the overrides of all the different parts of our shader. And then I created this PDG network. And without going into a lot of detail, this allows you to run a lot of tasks in parallel. So what we're doing here is baking out our original asset. We're taking all of our PNGs and all of our textures that were created in a paint package. We're converting them into the RenderMan format.tx. And then we're in a loop, taking those textures and those materials, and we're building our variants out of it. So I'm just going to jump back up now that that's finished processing, come down here to our set variant, and now you can see that when I go back to XPU again, I can now switch through our variants, and we've got lots of them. I think there's 15 or so now. And again, the nice thing about having XPU here for LookDev is that I can really use this almost as a debugging tool now. Because it's nice and fast, I can switch between my variants, and I pretty much get instantaneous updates. But I wanted to take it a little bit further, because XPU does render very fast, so I can sort of take things that used to require a render farm and instead run them sort of locally on my machine here. So again, I've just added to our template here, and I know this is probably looking a little complicated, but we're doing several tasks here. We're automating each one. So basically what this second section here is going to do is it's going to go through every variant we have, set up a camera, and it's basically just going to render those files out to disk, and then it's going to take those disk files and it's going to turn them into a sort of contact sheet where we can see them all together. And this is really useful when you have like LookDev that needs approval and things like that, or even if you just want to compare them. So this is something that you would typically send to a render farm, but I was able to do it locally using XPU, and this is the result. I can't give you exact timings on this because I was processing other things at the time, but I was getting about 6 to 8 images a minute. So that's very fast, 10 seconds-ish per image, which means that I could do this whole sequence really quickly instead of having to send it to a render farm, which is, again, really great to have XPU there and getting really nice looks out of it. Okay, so we've set up our variants, we've set up our assets, we've automated this whole process. Now let's start doing something with it. So I'm going to start out with just a point instancer. And now we're going to start taking advantage of, a lot of the interesting ways that you can modify your scene using USD. So first of all, I'm just going to dive inside my point instancer. I'm going to replace it with a grid instead of a point, so that we have a bunch of teapots. I'll make the grid a little bit larger. And basically every point on our grid is going to become a teapot. So this is okay, it's nice and fast. That's good. But let's start taking advantage of our variants. So obviously I could come down here and I could put down a set variant, and I could set it to something like, this bronze. And then I could go to my point instancer, and obviously now they're all bronze, and that's really nice. But similar to how, I didn't want to have to keep creating those networks for creating all my different variants, I don't want to do that here either. So we have a really handy tool called Explore Variants. And what that does is lets you actually see at once all the variants that exist on a specific prim, and basically allows you to select them, and actually a whole bunch of other stuff. But in this case, we're just basically going to duplicate those and create a reference to the original teapot and then set the variant. So it's just, again, more automation. And so now when we jump out and look at our scene, you can see it's sort of working, but everything looks like it's on top of each other. And that's because we just need to tell it that there's more than one primitive that it should be looking for. And we're just going to use an asterisk to do that. And now you can see really nicely we've got this field of all of our teapots. And again, let's jump over to XPU and take a look at that. And this is really just to verify our results. Again, we're still sort of in a look dev stage here. Imagine you were look deving a crowd or something like that. This is a good way to find out if things look correct, if they look the way you want them to look. And having it nice and fast like this is a really huge benefit. So earlier when we set up our shader in that template, one of the things we set up is this base color tint primvar, or primvar reader, I should say. And the nice thing is that primvars can be overridden just by using attributes. So I'm just going to come down here and say base color tint inside my point instancer. And you'll see that what's happening now is that we're sucking up that information from the geometry, and we're overriding the shader per instance. So now we're adding sort of variations on top of variations. So now you have this really powerful way of generating a lot of data, but then using it in more and more ways. And we can actually go a little bit further than that as well. So what I'm going to do now is start taking advantage of some, slightly more unusual options that USD provides. One of them is this idea of a class prim. We definitely don't have time to go into everything that it means to have a class prim or an inherit, but you can basically think of it as a special prim that is set up when you generate your asset, that your asset will sort of always look towards to see if there's anything it should add or change to itself. It's really useful. You can do all kinds of interesting stuff, but since we're talking about variants, what I'm going to do is create a new variant and add it into that class prim. Now, obviously, I could do this in a bunch of different ways, but what's really interesting here is that I don't have to worry about, where this thing is referenced in my scene. I don't have to look for it. I can always know that this class prim will exist under this class path. And so I can do things like add these sunglasses to, or I should say 3D glasses, to a specific variant in our already sort of instance scene. Once I've sort of set everything up, you can see now we get our 3D glasses, but only on the instance that we called flannel matte. So this is really nice. So you always have the power to go back and edit things, even after you've written things to disk, even after you've brought them into another scene. So we'll just do the same thing here. We've got some assets that are like horns, and we'll apply them to our sort of scaly teapots. So this is really nice. So now you've got this really awesome way of editing things at this very high level, almost secretly in the background, by using this class prim and inherit. And you can actually take that even further and say, well, now I want to override all the instances. In this case, we've just added this hat. We're going to rotate it because it's facing the wrong way. But now we've got this hat, we've got these eyes. So you can see we can put together huge amounts of variation by taking advantage of the mechanism that USD provides and the sort of procedural layer that Houdini provides on top of it. So now we've sort of walked through all those examples. Let's take a look at like an actual scene sort of built using those techniques. And it really is just the same 2 or 3 techniques over and over again. So in this case, we have created a crowd simulation of these teapots all moving towards kind of one location where they're all gathering together and having a bit of a tea party, I guess. And you also see a really nice performance here in the viewport, thanks to being able to write all this stuff out to disk. But essentially, we're just doing the same process over and over again that we've already walked through. We bring in some rocks, we do an explore variance, we instance those rocks into these interesting sort of clumps. We already wrote out this background as using our template. It's really just a basic texture map, basic material on some ground. Up here on the right, we've brought in our teapot. We've done the exact same thing. We've done an explore variance and a point instancer. And you can see that it loads in and brings everything fine. And you can check out how the teapots are running around in the background. Now let's talk about working with this, because we actually have lots and lots of different ways now that we can interact with our scene, right? We have variance, we have point instancers, we have the attributes on point instancers, we have the ability to edit properties. So there's lots and lots of things you're changing. So how do you work with that? Well, I'm going to do a very high level version where I've just set up a basic scene with a dome light. And now I'm going to take a snapshot of that. You see it show up in the gallery there below. And then I'm going to edit my scene. Now I'm doing these very high level edits just for speed, but you can imagine doing some of the things we talked about, overriding the class print, setting variance. In this case, I've just added a point light to each teapot, so they're sort of carrying a colored light as they go. So I'll take another snapshot of that. And now let's try without the dome light and just the sort of point lights, because that kind of gives an interesting, colorful disco sort of look. And we'll take another snapshot of that. So now we've created these three different versions, but we've modified our network each time. So I'm just going to pop up this larger one so we can get a look at our images. And when we click between them, you can see, they're all okay. But let's say I wanted to go back to this one. Well, I can revert the network to this snapshot. You can see on the right, the network has actually changed. And behind here, we've already started rendering that previous image. Or we can say revert to this one. We're going to reconnect our network, and we're going to disable our dome light. And again, immediately we start rendering. So basically what this allows you to do is, when you're dealing with all the complexity that you're offered with all these different ways of overriding things, you sort of have this extra protection on top where you're working in this kind of non-destructive way where you can change settings, take a snapshot, but you can always revert back to where you were. And here finally, I just wanted to pop open a full render of the XPU so you can kind of see how quickly you get an image that's worth sort of investigating. It may not be like full final quality image. And of course, like a real scene like this, you might have volumetric, you may have all sorts of things. But the really nice thing with XPU is that you can see almost immediately you have enough to go on. You have enough to judge what you're seeing. And here's just the final version of that image after it's cleaned up. It really didn't take very long. And I know that was sort of a whirlwind overview of things that you can do with USD, Solaris, and XPU, but thank you very much.
Thanks, Scott. That's awesome. I'm gonna have some dreams of swarms of teapots tonight. Borderline nightmarish, but that was super awesome.
Thank you.
So we'll bring back George, and we're going to also be joined by Katrin from the RenderMan team for some Q&A. Katrin, would you like to introduce yourself?
Yeah, I'm Katrin Bratland. I'm a software engineer on the RenderMan team, and normally I work on RenderMan for Maya and RenderMan for Houdini, and lately I've been part of this effort to make the RenderMan Hydra plugin available with the rest of our products.
Awesome. Scott, you can come back for awesome. So I actually think the first question would be for you, Scott. Is the snapshot gallery saved with the HIP file?
Yeah, it's sort of saved alongside the actual images, and it is saved with the HIP file. So when you load it up, you'll have your same gallery that you had previously.
Awesome. The next question is, how do you choose between which of the USDA, USDC, and USDZ to use in a pipeline?
Oh, that's a good question. So basically, USDA is kind of our human readable version of the file format. So you would use it for typically smaller amounts of data, usually scene assemblies, things that isn't a whole lot of data, but it's actually useful to be able to search it with Grok and things like that. USDC is optimized for a boatload of data, so it's a binary format, super highly optimized. USDZ is kind of it's a slightly different beast. It's a package, so it can store both USDA and USDC and some texture files as well and everything. But basically, it takes your entire asset and packages it up so that you can transport it easily. You know, and it's the format used in the Apple AR stuff. The teapot is a USDZ file, so that's kind of where you would use USDZ, is if you want to take, you know, a self-contained asset and transform.
Thanks, George. Let's see, we got some more coming in here. USD supports volumes. Yes.
Yes.
I guess that's an easy one. Send in some questions. I guess while we have this little lull, I'll have a little shameless plug. Actually, the RenderMan and USD teams are both hiring right now. So if you're looking for somewhere to work, check out the Pixar career page. So I guess we can kind of talk about some of the previous ones and maybe elaborate on, can you explain how XPU uses RAM, GPU RAM, and limitations? Ooh, we might have to get an answer to you with a message from the team. What does porting a pipeline to USD look like? I hear a lot about studios moving their pipeline to a more USD focus. What does that mean for developers?
That's interesting. It's a little bit open-ended. It could, I mean, there was a few talks at SIGGRAPH, I think it was 2017, 2018, about studios, major studios porting their pipelines to USD. So you could look those up again and have a look at it. What that might mean for developers is if you have a lot of you know, custom software that you've written that reads your data from you know, particular sources. Usually, you know, that's pipeline glue type software that that lets you massage data as it comes in from one application to the other. Well, you know, porting it over to USD would mean rewriting some of that software or adapting a little bit to read USD instead of whatever format that it used to read. The nice thing about USD is the more and more of the kind of the major GCCs are dealing with it natively, and we're trying our best to make sure that it stays, you know, more or less compatible between all the applications, you know, without folks kind of having to do custom stuff. So, yeah, I don't know if I answered that well enough, but there's, you know, maybe it depends on the studio, and it depends on your pipeline specifically about what it might mean for you, but it would probably mean writing some of your pipeline code to actually be USD aware.
This one might also be for you, George, but how would you go about, or maybe Scott, how would you go about exchanging rigs between DCCs using USD?
Scott, you want to handle this? No, I'm just kidding. No, I'm just kidding. So rigs is a good one because famously USD, we don't have schemas for arbitrary or for codified arbitrary rigging. We have schemas for USD scale, which support post blend skinning and blend shapes, and so you can transport, you know, a fair amount of functionality that way, and it depends on the DCCs about what they actually support on the consuming end and on the exporting end. For general rigs, so far what folks have had to do is develop their own schemas, and so what you could do in your application is develop a schema that would make sense for you in terms of the data that you do want to transport between DCCs, and then currently, that's unfortunately the only answer that we've got, is that it requires quite a bit of custom development. The rigging question comes up a lot, and it's something that we're currently very much scratching our heads at.
Let's see, next one. How would someone work with render time procedurals like hair and fur? Scott, do you have a sort of Solaris workflow for hair and fur that you've, you know, been talking about?
Yeah, so there are these things called dynamic payloads. which are sort of like procedurals in a way. I can't speak generally how you would set this up, but in Houdini, you can basically create an HDA that has whatever processing you want in it. And when you go to render, it will use the HDA to generate whatever you've asked it to generate, hair or fur or something, at render time. So it's not quite the same as a procedural because you're reading it from disk and then processing something from disk as opposed to reading something from the scene. But in practice, that's almost always what you do anyway. So it probably all works out in the end. But you definitely have ways of doing that.
There was a question about Python 3 support in Houdini, and that is supported in RenderMan 24.1 for Houdini 18.5. Let's see, back to the list of, they're coming in fast now. Awesome, guys. Let me, how does USD work with huge geometries like big water caches? Is there a way to compress or break it into multiple parts?
So you can definitely break up your geometry. It requires a little bit of development on your end to figure out how you want to represent it. As there's nothing in USD that you could call that would break up things automatically, but that's what Houdini is for. And so you can definitely use the Houdini tools to do that sort of stuff, and then you can export that to Houdini or save it out to USD, and that should be all fine. As far as compression in USD is concerned, we do have support for geometry compression format called Draco. It's on our GitHub. You can download it, you can build it, and you can add it to your suite of tools for USD. But that would allow you to compress data that's stored and carried along with USD files. The trick there, of course, is that you have to make sure that whoever's consuming it on the other end also knows how to decompress Draco. So, but if that's all within your own pipeline, that should be very manageable. Draco is a cool compression, geometry compression software that's made available by Google. So.
Just to jump in here, it's not exactly related to compression, but a really useful thing I found is having a compressed or poly-reduced version of your surface to use in the what's called a purpose. So when you're looking in GL or you're doing your lighting, you'll have this sort of low-res, still representative thing. And then you have a render purpose, which is your full res one, which you probably don't want to load all the time until you're actually ready to render. So that can be a really nice workflow too, where you have sort of two slightly different versions and only pulling the high-res one when you're actually doing your real renders.
Yeah, that's an awesome point.
So what are the best cases to use XPU? Specifically, can I blow stuff up with volumes? So this is a great question. So XPU currently targets look-dev workflows. Volume support is currently limited to single soldering and surfaces, but we are actively working on volumes for XPU and 25 and beyond. Can you explain how XPU uses RAM and GPU RAM limitations? So for 24, we recommend 24 gigabytes of VRAM on the card for production scenes, typical in a VFX. XPU is very good about compressing geometry on the GPU and uses texture castring so that it doesn't require all textures to fit in VRAM. But a healthy amount is still essential. Do we support OSL shaders and custom integrator shaders in Variance?
Sorry, can you read that again?
I'm not sure. I think they're asking if you can have like shaders as variants.
Yeah, absolutely. So yeah, you can definitely. There's no restriction to what you can put inside of variants. Is that true? Yeah, I think that's true.
Is there a way to specify renderer-specific attributes when writing out a USD so you can mix and match renderers cleanly? Or does Hydra handle that abstraction?
Oh, that's a good question. So yeah, so part of the old kind of the existing Hydra APIs, it's actually kind of difficult to get renderer-specific data from the scene to Hydra. And so with the new stuff that we're doing, that'll become much easier. Now, a totally different question is how how you actually encode that in USD. And in USD, a lot of our schemas have namespaces, and in particular, you can codify things according to your renderers. So the kinds of things I mean by that is, for example, your material bindings or your shader outputs. There's a render context namespace that you could put on that, so you can actually have the material binding pointing to a single material, and then your particular terminals having a specific one for RI or a specific one for GLSLFX is what our Storm one is called, and for example, any other renderer that you might have.
Can USD be used in industries other than VFX? That's a broad and open one.
Yes, in fact, it can. There's a bunch of places that are using USD that blow our mind. If you come to the BOF, you'll hear about some folks using USD outside of the VFX industry. There's really cool applications. NVIDIA is doing really cool stuff with it, and their Omniverse product. Apple is clearly doing some non-VFX things with USD. And yeah, there's a lot of really cool stuff with to do with it. We've even heard of people laying out their networks with USD, so it's kind of interesting.
Does XPU ultimately require a RIB byte stream to render? So no, RIB is not quite suited for interactive rendering, which is what XPU excels at. So we have a different API that allows for faster edits. A lot of USD questions. So George, I'm probably going to put you on the spot again. Does USD enable a shading pipeline? Does it provide the glue between geometry and shaders?
Yep. So what you want to look up is a domain. So our schemas are broken up into what we call domains. And so kind of USD geom is our geometry domain, and USD shade is our shading domain. And you could look that up in our documentation. But yeah, you absolutely can. We have schemas that let you, bind geometry to shaders and, specify primvars on your geometry to, presumably control some of the properties on your materials. Yeah, totally supported.
So, go ahead.
I was going to just jump in to add that, like in Solaris, you can just use your RenderMan patterns and shaders that you're familiar with in RenderMan for Houdini. Those all will work in the Solaris workflow as well.
So that kind of answers what is your recommended approach to handling materials made up of shading node networks in USD? Is there anything specific, or I think Katrin kind of answered this one. So it seems, here's another USD one. It seems that USD is primarily for finished geometries, so swapping them as assets. Is there a mode for breaking geometry back into points and NURBs and planes?
Yeah, so you can, it's interesting, like finished geometry, it's like, you mean maybe just for export? It doesn't have to be. You can, there are schemas for point schemas and things like that. You have access to all of that data. We have a NURB schema. It's not fully fleshed out, but it exists. And I think there's some questions that are and discussions happening on our interest group, which, by the way, if you're interested in talking more about USD with the wide community, our biggest kind of forum for that is a Google group called USD-interest. So you can log on there and check out a bunch of questions related to that kind of stuff. And also there's our GitHub issues page. So yeah, so for NURBS we have some schemas for it, but they're not fully developed, and we don't have full imaging implementations for those. But we're happy to take PRs, and so that's, I think, part of the requests that are happening right now in the discussions.
Just to jump in with a Houdini plug, I guess, in Solaris and Houdini, the boundary between USD and the rest of our sort of geometry handling is pretty permeable. So if you did have a USD asset and you wanted to edit the geometry or do something to it, you can sort of pass it to the geometry processing part of Houdini and do things with it, and then move it back into USD if you want. So obviously everything George said is totally correct, but we have some workarounds you can do in Houdini because everything is sort of tightly integrated with the rest of Houdini.
So we've got a couple like roadmap questions that I'll try to answer here. So the first one is, any plans to implement a distributed render for a single image? So yes, we've considered it. We have no concrete plans yet, but we might have more information going forward. Another question was about limitations in RenderMan for Solaris, specifically motion blur and volumes. So this one's a little complicated to answer. So some of them we've addressed, but as every dot release comes out, we try to address more and more. And we've been working with the USD team and the SideFX team as well. So and I guess their follow-up question being, are people using it for full production? So some studios are using it for final frame, some not yet. So maybe. Let's see. I think we've answered. Oh, here's a kind of an open-ended. Talking specifically about Usd instancing, native versus other options. I would often run out of VRAM with verts counts when doing lawns, for example. One way to clear cache was closing Houdini. Scott, do you have any sort of USD instancing tips?
Yeah, I mean, it really depends on what you're trying to accomplish, I guess. A point instancer or true instancing, I guess, is sort of the best and most efficient. I don't even know, you can render insane amounts of geometry if you use a point instancer. And then it sort of gets more and more resource intensive as you go to instanceable references, which are still quite good, but obviously a bit more limited, and then just pure references where you're almost duplicating the geometry, not quite, but sort of. So there's sort of a price to pay and then more flexibility as you get to the more costly versions, and sort of more strict rules as you get to the very efficient one. So it really depends on what you're trying to do. If I was doing a lawn, I think was the example, I would definitely attempt to use the point instance or true instances, because those will be far more efficient than just about anything else you could do.
Thanks, Scott. Anyone else have anything to add, or? That's fine too.
I've got this.
Does Pixar use Material X in-house? How likely do you think it'll become an industry standard like other open source projects have become, such as OpenEXR?
So we, as far as I know, we don't have any productions that are using it in-house. We added support for it as part of, we got an Epic Mega Grant that helped us find some funding so that we can implement it. So we have one of our really awesome engineers implemented all of that. You can hear her talk about it at the Material X, at the ASWIFT Open Source Days, and that is happening tomorrow at 1:30, I think, PDT time. So anyway, just a plug for Karen and the Material X folks. So yeah, so that's so that we have support for that. And I can't predict what's going to become industry standard and what's not going to become industry standard, but we're definitely doing our best to support it and hope that it does pick up and become something awesome.
Here's another one about RenderMan lights. Can they be easily created in LOPs? So yes, I believe that was part of Scott's demo at least. So yes. Is there any open source USD editors? George, I don't know.
Yeah, there are a couple of projects out there that I don't know if they're full on USD editors, but there's some stuff out there. I'm going to have to refer you to Google. There's also there's a couple of lists that you can go to as well that list a bunch of open source projects that have to do with USD, like support for USD. There's a wiki maintained by the Academy Software Foundation that's really good, and a couple of other users have it on their GitHub as well. So check that out. But I believe there's definitely interest out there in building them, and there are a few, like some actually cool work that folks have been doing. But I don't know. I don't want to get anything wrong by saying it.
Google is always a good resource. Let's see. So is it possible to render USD files from the command line with RenderMan? At the moment, no. We've thought about doing this, but at the moment, I don't know if we have any like a timeline to give for that.
But it is possible. I mean, we don't provide a tool right now with the RenderMan package, but Solaris has a command line tool that will allow you to render with RenderMan. It's called Husk. And that will even, in Solaris, you can even use your familiar RenderMan display drivers, so all the file formats that you're used to rendering with RenderMan. And then as part of USD, there's another command line rendering called USD Record, which will not go through the typical RenderMan display drivers, but it is another option.
Yes, thanks. Sorry about that. I totally forgot about Husk there for a second. Yes, thanks, Katrin, for that. Let's see, there's a lot of questions scrolling through here. Does USD support curves between applications? For example, to use as 3D drawings?
Curves, yeah. So we have a pretty fully featured curves schema that's used. In fact, there's another Google product called Tilt Brush that actually used USD and used curves from USD, or it had the ability to save out to USD, and then you could bring those curves into other applications that support USD. Does that answer the question? Does that kind of?
I think
Did
so.
I understand that right? It was about curves?
Yep. Mm-hmm, yes.
Yeah. Yep. Full-on support for curves.
There's also a question about Solaris documentation. I believe there's SideFX has a ton. So Scott, what do you want to talk about that?
Yeah, there's documentation, obviously, but there's also lots of tutorials, getting started stuff on our website. I would definitely start there if you wanted to find out some things. There's RenderMan specific ones and then more generic ones. So there's lots of stuff to get you up and going if you wanted to try it out for sure. So I would start at our website, SideFX.com.
This is a question about the difference between Python 2 and Python 3. So on the RenderMan side, we're just supporting both of them. There's no extra functionality in one. I don't know on this Houdini side if there's anything extra on one. Scott, do you know?
I don't believe so, but I'm not entirely sure. I'll have to check out an answer for that one.
Let's see. Looks like Maya is being used by Pixar in parts of the pipeline. We are considering moving to a USD pipeline. Is Maya's implementation of Usd in Maya 2020 ready for a fully USD animation pipeline?
I could talk a little about that. I mean, we've recently added the RenderMan Hydra plugin to our RenderMan for Maya package, so it will work in Maya 2022. It's not very fully featured in terms of render settings. So like the Maya release stated that this is their Maya to Hydra is kind of targeting layout right now. And I would say that's kind of where we're at in terms of providing render settings too, but it's in there for you to try out in the next, or it should be there in 24.1 actually.
Yeah. Okay, well, we are out of time now. Thank you everyone for joining us, and thanks to Katrin, George, and Scott for the wonderful presentations and Q&A. Hopefully you guys can head on to the next presentation. Thank you all.
Thanks, everybody. Thanks, Sarah.
Thanks, everyone.